to any work around CQ5. It's challenging, the topic itself, I think, but at the same time, it's pretty interesting as well. I think, just because the promise that it holds in terms of improving the overall quality of the end result, the deliverables. And Sagar is certainly expert, I think, having worked on the Denver side, on the Time Warner cable, which are really heavy on the automated testing, not just from the functional perspective, but even from the unit testing and the JavaScript testing perspective as well. So we are certainly, I think, looking forward to hearing more about different tools that you all use and some of the lessons learned from that. So,
Great. Thank you, everyone. Thank you, Josh. Yes, you're on the line, and someone else also. Good evening. So my name is Sagar. Today we'll be talking about TDD in CQ5 and AEM. So test-driven development in general, we'll try to cover what it means, why is it useful, what was my experience of using it, and kind of try to apply how we can achieve TDD or in general testing in CQ AEM applications. So, all right. Getting started. What's on the plate today? As I said, we'll cover briefly, what is test-driven development in general, what it is, why is it useful. I'll be also talking briefly about the theory of BDD, which is kind of an offshoot of test-driven development. BDD stands for behavior-driven development. We'll try to give some examples of how we can achieve testing in CQ. Especially, I'll be focusing more on the backend part of CQ. So, in CQ backend we have osgi services, servlets, component models, and things like that. At the end, we'll also be looking at some live code. So, I have a simple test project set up, and I'll be going through some simple exercise, not exercises, but simple examples of how you can have, achieve testing in CQ. I'll be also introducing, introducing a framework called Spock, what it is and why I like it so much, as opposed to something else. Along with that, some things that are not going to be covered in depth today. Advanced testing techniques. So, obviously, if you talk about testing any software in general, there are various types of testing that you can have. You can have unit tests, you can have integration tests, functional tests. These are the main three. Then you can talk about UI testing, browser automation. You can talk about smoke tests. Lots and lots of other things. We'll not be going into all those specific details. Also the framework that I'll be talking about, Spock framework. It is an enterprise-ready framework, so it has got several powerful features which makes it easy to test virtually any kind of Java Groovy-based application. I'll not be going into all the obviously details, but kind of give an overview and go into a little bit details. Also, we'll not talk a lot about JS testing. We have been recently doing some JavaScript testing, the project that I work on, but it's still in a nascent state. It's not mature enough. Spock testing, on the other hand, it is. We have been doing that for a while. So hopefully this is interesting for you all. Except that, a little bit about myself. So I'm a software consultant, tech lead over here, and I'm basically working in the web space, primarily doing backend development for CQ AEM applications. So I'm comfortable with Java and Groovy. In general, JSP obviously. I don't dislike front end either. So I have been doing some front end in the past before I actually got on this project. So I do like JS a lot. I've been studying jQuery to be specific for a while, but recently for more than a year I've been doing mainly backend development. So on that note, let's kind of jump into the topic today. So here is a statement that I recently saw somewhere, and this is really interesting to me, and I started believing into it. I think it was like a couple months ago, but this is really interesting, right? I became a programmer because of science in programming, but remained a programmer because of the art in programming. So obviously, coming from a computer science background, you have to know about algorithms and data structures and so on and so forth. You have to be clever and you need to know, bit manipulations and things like that. But what this statement claims is if you want to really stay as a programmer or as a good programmer, you really need to know the art of programming. So what does this mean? Why art of programming? Over the course of this talk today, we'll try to answer some of these questions, and hopefully testing will be a big part of it. And what all testing can lead to. So, TDD. Depending on who you talk to, some people are very aggressive about testing in general, and some people are not. But some people are like, I have to have tests for this code, otherwise I'm not going to review your code. Or, I have to have at least X number of unit tests for this big service that you have written. And sometimes it is really, really true that it may not fly to the, to the main architecture of your project if you don't have any tests. And sometimes for especially, new people coming on the project, young people who are coming, straight from, their studies or whatnot, it can be intimidating sometimes. So I'm not going to try to enforce that you have to do testing. I'm going to kind of lay out my experience, why I think it is useful, and kind of talk about test-driven development as as from what I perceive it is. So in short, I really think of a test-driven development as a milder approach of the first point over there. So I really think about test-driven development as writing a lot of tests. Of course, if you think about what's the technical meaning of test-driven development, it is really all about writing tests first before you do anything else. So obviously, it's part of it comes out of the extreme programming agile methodology, for example, there is a new requirement that business has given you. This methodology enforces you to write a use case test for that use case first. Make that test fail, obviously, because you'll be writing a test for the code that doesn't exist, and then write the code that passes the test and iterate over that until your code reviewer is satisfied, basically. But I really think that approach might not be plausible in all the cases. Say, for example, there is a project which is already going on for a while, a big enterprise level application project going on for a few months, and they want to start using TDD. It's not going to be easy to change the culture of not writing tests to just write tests first and don't do anything else before that happens. So what I'm going to try to focus on is writing tests in general, and then kind of go into how you can kind of ease into this methodology in general. So having said that, as we are talking about CQ AEM specifically, I wanted to kind of give a brief refresher of what a unit test is in CQ or AEM. Especially, again, I'm focusing mainly on the backend part of it because there are so many things in the AEM technology stack. So what could a unit test mean? Obviously, if you look at say an OSGI service in CQ, and a unit test in that would be to simply test the activate method of your OSGI service. So as you know, there is a simple there is an activate method for every OSGI service, as well as a deactivate method. A unit test would be to just see if the service gets activated correctly or not. Similarly, if you talk about another facet of the AEM backend stack, a sling servlet, a simple unit test for that sling servlet could be, say a servlet accepts post requests. All you want to do is to see if post requests for that are executing or not. At that point, obviously you can have detailed unit tests later on, but it can start off with I have a request and do I get a response back? Is my servlet working as I want it to? So again, this will be more clear when we try to look at some code later on, but kind of this is a refresher. So at this point, I would like to stop and see if there are any questions before I jump on into some bit more details and benefits of testing. All right.
When did you start writing on this?
What's that?
When was the first time you started writing on this?
Probably the first month I came on the project, so April of last year. On the specific AEM project.
So on the Kamana cable network side, I mean, you guys write the unit test or the test first before writing the code?
Sometimes I do, but again, there is an influx of new and old people, new project members and old project members, so they have kind of different thought process. So it's not a strict rule that you have to have new unit, first test first, but there is definitely some kind of rule, at least on the checkout part of the tier 10 project, to have tests for sure. It won't be accepted if there are no tests for that.
Okay, but they don't have force to write the test first.
No.
It just has to be part of the code.
It has to be part of the code at the same time as the new code is in, for a new code review, request, there has to be, if there is a new code, there has to be tests to support that. Otherwise, it's like, I don't know what's going on. All right. So, obviously, if you think, if there are no, say there is a project who doesn't really adopt testing that much, or, it's like, I do test sometimes, but not otherwise. Benefits of testing really coming to, have a huge role over here. So we'll kind of go through what I think are benefits of testing in general. First one is obviously find bugs early. Say for example, you have some important piece of code which say talks to a database or something, and retrieves user results, user information or something. If we have tests backing that piece of code, say that's a critical code of your application, it is going to be invariably easy for you to find bugs early than in production, which is obviously not a good idea. Secondly, a new person comes onto the project. This actually happened to me because I was thrown into the part of the code on the project which was not really intuitive. It was not easy at all to understand as a newcomer, especially. So, but fortunately, that part of the code had already some unit test, unit test helping to understand it. So that's what my second point tries to say. If a new person is coming on the project and he is not able to understand the code, actual implementation, if there are tests, and if they are actually designed in a way, we'll talk about why Spock will help in this case, the Spock testing framework. Reading the test will actually help him understand the implementation, hopefully a little bit better. Obviously, there are people going to be helping him out and whatnot, but this is one of the important points over here. So, third one, improve code quality. If your project, that you're a part of, has a good amount of testing, I believe that invariably you will be forced to follow good programming practices. So I'll give a brief example over here. What do I mean by that? So again, let's take an example of a simple component, right? You have a list, you have a table component or something, right? And there is a component model for that, and that model is backed by a couple of osgi services who are making some external database calls, for example. It will matter how you write the code, actual implementation code, if you want to write good tests. So what I'm trying to get to is, good programming practices like dependency injection or using factory patterns to create your instances or things like that will help, obviously, to improve the code quality, but along with that, also make it easier to write tests. And again, we'll see how Spock can help us in that, but one of the important points to kind of note over here. A few more. Over a period of time, any enterprise application grows so huge that there is a need to refactor some part of it at least. So say, for example, there is some piece of implementation of your enterprise code base which has not been touched for a long time. It is literally like a dark room in your grandma's house. No one really wants to go there because I don't know if I'll be able to get out of it. But because of, say, there is a requirement, right? There is a feature request, a new feature request which has some enhancements on that old code, or there is a bug fix on that, right? You have to eventually refactor. Same point over there also. If you have tests backing that, you will be a bit more, eased out while refactoring. So if you have tests for that implementation that you're trying to refactor, if you mess up the refactor, you'll know because the test will fail. So before you open up the refactor for code reviewing and before it goes to production, if you have tests, people will be able to, you'll be able to find out, oh, I didn't do this, I need to fix it because the tests are failing. One more important point, and this will be really apparent when you look at some examples of spock testing. Some of you already know about it, but I really believe in this. A good test is worth 1,000 comments. So doesn't matter if you have a complex logic in your method doing crazy looping and conditionals and whatnot. If you have tests which explain exactly what use case you're testing, so I'm testing this use case over here where there are like these 10 different kinds of inputs. This is literally like a comment for your source code. So again, tests are important, but good tests, readable tests are more important, I believe. It doesn't really help if you have convoluted tests written for some functionality, and that's not going to serve purpose that much. And last point is really kind of tacking on to the point before is, it is really executable documentation. You can, at this point, say you have a good test, you're able to read the code, read the test easily, and you can execute that. So if it is worth 1,000 comments, it is eventually going to be executable documentation. So, any questions up till now?
Does benchmarking ever fall into testing? Integrated testing at all?
It does. It is kind of, performance testing would be one, right? That would come later in the stage, I believe. For a developer, I'm trying to focus a bit more on the developer side. If you talk about developer trying to write tests, he would really want to have good code coverage for his tests, unit test and integration test, not so much benchmarking at that point. I think over iterations, you will get to that eventually, but not at the start.
So on an average, what percentage of time do you see you guys end up spending on writing tests versus writing code?
To start off, it does take time, because especially if you don't are in that mindset of verifying what you're trying to write, it can take time, but over a period of time, it will kind of become ingrained in you that it will actually become, if you'll feel incomplete. I have written this code, but I don't know if I'm considering all these cases. So over a period of time, it will get quicker. And if you talk about timing, I would say it's like on an average, say 70 to 30. So 70% of time you'll spend on implementing it, 30% will be to write tests and verifying that implementation. All right. So coming on is a related topic, BDD, behavior-driven development. So this term was really was coined by a person called Dan North. He has his website where he explains kind of the history of how he came to it, and if you go and read that, you'll really see what he means in a nutshell is behavior-driven development is really test-driven development done well. So what do I mean by that? BDD is all about writing tests from the customer's or stakeholders' point of view. It is more expressive than test-driven development. It is really, if you think about it, behavior-driven development is really test-driven development that you would want to make it more expressive, more easy to understand, and again, we'll be looking at Spock framework, which kind of is inspired from BDD methodology, which is, again, as I said, TDD done well. So we'll look at what exactly I mean by that as we go on. So let's take a look at a simple use case over here. It is not fancy. All it is trying to do is it has some variables, V1, V2, and so on. It has a system and there is a method called execute feature on that system, and we have some expected output of that execute feature method, and then we actually execute the feature and we get the actual output. And all we want to do in this test is assert if the actual result is equal to the expected result. So a very simple use case of when you would want to write a unit test or any kind of test, and how could you model it differently? Those who know about JUnit or in Ruby world, if you know about RSpec, the next part is going to be a little bit familiar, especially if you know RSpec for the Ruby testing framework and a couple more. Then this is what I'm trying to get to. So at this point, I want my test to be easy to read because it's almost as a comment, it's almost as a documentation for me, right? As we saw before, I want it to be easy to understand what it's doing. So at this point, enter Spock framework. What is Spock framework? Spock framework, as I said before at the start, is really enterprise-ready testing framework for testing Java and Ruby applications. So on that note, obviously it can be used for testing your CQ, AEM, backend architecture. What makes it really stand out from other other testing frameworks like JUnit for Java, there is also JBehave and a couple others, is that it is really it is highly expressive specification language. As I said, it is kind of derived or inspired from behavior-driven design, so it is different, and we'll see examples later and kind of hopefully make out that it's different. Some people also say that Spock is really next generation of testing framework, so it is kind of, I think it is kind of lessons learned from some of the older frameworks that were being used in Java and so on. Why is it awesome? If you look at the actual tests, they're actually really nice to read. It's not cryptic, it's not some random function that test should do something kind of function, and you're not doing JUnit kind of testing. It's different. It is powered by Groovy language, which is Java on steroids, basically. So it is easy to learn. If you know Java, it should not be that difficult to look at the syntax for Groovy. And lastly, they say that it is enterprise ready. So they back it up by saying that there are several Spock extensions. Like they have some extensions for Spring framework, which is used in enterprise, in a lot of places. And they have extensions. I'll not be going into detail what they do, but they also provide APIs to build your own custom extensions. So we'll look at a couple of them, a couple of inbuilt extensions as we go forward, but it's kind of why they say that it's enterprise ready. And so obviously from inference, it can be used to test your AEM CQ backend, your services, your servlets, your component models, and whatnot. So after this, we'll be going into some code examples of what it can look like. Any questions up till now?
So what exactly is the difference between JUnit versus Spock, apart from Spock running on Ruby? What's the big difference that you've seen?
The big difference that I've seen, I think that even that project was using JUnit before they switched to Spock. One of the big things were, I think, if I remember correctly, JUnit actually lacks in some of the things that we were trying to test in CQ especially. Spock has some really powerful APIs for like mocking and stubbing, or some other things. So that is, I think, and also it is just more fun to write Spock tests.
I believe JUnit is imperative and Spock is declarative. Okay. So it's much more semantic and easy to read.
Mm-hmm. Yeah, and we'll look at an example. Actually, let's do that now. We'll look at an example. Here is an example of a simple Spock feature, as they say. So what they want to say is, I am not really writing a test, but I'm writing a feature for my system that I'm trying to test. So everything that you have as tests in Spock are really Spock features. And this is kind of a generic example of, say you have a simple component for your simple component in CQ, there's a component model, and you want to test if it gets instantiated correctly or not. As I said, at the top, you will see that the name of the test is a complete sentence. This also makes a difference because if you look at the test reports, for example, at that time you'll see the difference that having a function as opposed to having like a complete sentence, it's more semantic, as Scott said. It's easy to read, and there are these features, clauses like given, when, then. So it will basically say that given the variables with some initial conditions over there, when my component is created with those initial conditions, I want to then see if the actual instantiation is equal to the expected instantiation. So it's kind of easy to read. It's not it's not cryptic. You'll understand what it's exactly trying to do. Hopefully, if you design good tests, So this is kind of a simple example, and now we'll try to kind of go into some code examples, real examples. What I'm going to do is kind of show 3 examples of writing unit tests, writing tests using Spock. One will be to basically test a simple OSGI service. Second will be to do a simple unit test on a sling servlet. And the third one will be to write a functional test on a simple servlet that's running on CQ, author instance. On that note, let's jump in. So there is a simple interface, hello world, that has a simple public method, get hello. And if you look at the implementation for that interface, it is an OSGI service, as I said before. It has activate, deactivate, and a public method which returns a static string. What is that? Right. So as I said, at this point we don't really want to focus on what that service is doing, but how you can test that service. So that's why I've kept it a bit simple. We'll go into a bit more complicated ones relatively later on, but this is kind of a start. Okay. So hopefully this is visible for everyone. You good? All right. So kind of the definition or the syntax as we make for writing a simple Spock test. I had a hello world service, so I'm going to name it hello world service Spock test. This actually is named a bit differently if you're using different build tool. If you're using Gradle, then you would really name this hello world service spec. But because I'm using Maven to test this, I was not able to get spec, the naming convention using spec run work out because Maven looks for test at the end of the string or something. So the important point over here is you need to extend specification, which is a class provided by Spock library. If you want to write a test, you need to extend that basically. Couple of important things. There is a implicit method called setup spec. There is an implicit method called cleanup spec. What are these two doing, right? So as I mentioned in the comments, setup spec is going to be run by Spock before the first feature or before the first test is run. So it's kind of used to set up your whole test suite. Here, say in this case, there is a service that you want to instantiate and activate and so on. Similarly, in cleanup spec, it is going to be run after the last feature. So in that case, we'll be deactivating that service in this case. And another important point which I would like to point out is this. So as you all know, an activate method on an OSGI service takes in a component context instance. In this particular case, where we're trying to write a simple unit test, we don't really care about what that component context contains, but we just want to make sure that the type that's passed in is correct. So that's where mocking API of Spock comes into picture, and it's really powerful. It can be used for a lot of things. There is a good bit of documentation on their wiki for Spock, and it's really awesome. Just want to point that out. And starting off, it's a very simple test. My test basically says that it should work for the method get hello, and all it's going to do is expect that hello world.getHello is going to return a static string that I have mentioned or not. So one last thing to point out before we actually try to execute this is this add ignore annotation. Obviously, as you can tell, it is used to skip test if you want to, and a good thing is you can actually say over there in a string, say why you're ignoring it, and which really becomes useful if you're looking at the test, because that's what the point of this is, to be able to read the tests, not just write the tests. So let's ignore it and quickly run it. So MVL clean test. Obviously this will pass because it's a very simple one. Build success, and if we go and look at some details, I have total 4 tests, but 3 of them are skipped. That's why just one right now which I ran, and which is this one. So hello world service spock test run, 1, no failures, no nothing, so it's good. This is kind of a start, not that interesting. We can do some more interesting things as we go to the next one. So, second example. I have a sling servlet, which is extending sling all methods servlet by the sling API, and all it is doing is it is accepting GET requests only, and all it's doing in the do get implementation for that is returning a string again. So it is doing similar thing as we had before in the service, but to test a servlet is a bit different than to test the service, especially in CQ implementations. So, looking at the code now. Similar naming convention, my awesome servlet spock test, extending specification, it is ignored right now. And over here we have some shared variables declared at the, as a members of that class. So what does the add shared annotation do over here? Add shared basically lets you share these variables, if you may, across different tests. So you'll see how you can use it later on, but that's basically what it means. So I have a variable for the servlet itself. I have a variable for the request, for the response, and one more. So setup spec again. So as you can see from before, to compare, this is doing a bit more than what the other one was doing. So at the top, it is instantiating instantiating the servlet using a public constructor, and then it is doing this on the request and response objects. So as you know, a sling servlet or any kind of servlet has a request and response that you need to pass in the doGet method if you want to test that. Again, this is a unit test, so we have to actually call the method. You're not going to call the servlet by the servlet path, if you may. Again, I'm using the power of mocking, so I don't really want to have the details about what the request and response objects are, but I just want them to be of the types sling HTTP servlet request and sling HTTP servlet response. And lastly, this is interesting. Operator overloading for the right shift operator. What this is doing is, whenever in the actual code that we're trying to test, if Spock encounters a method call for response.getWriter, all it's going to do is, if I get that method call, I'm going to return what's there on the right hand side. So it's not going to go and execute the execute getWriter itself, but it's going to just kind of short circuit over there and return what I have on the right hand side. This again becomes handy, comes in handy because you might have various functions in your implementations and you only care about, say, 2 of them. You can do that overloading over there and kind of, make your life easy. Simple tests again, as they are supposed to be. 2 tests. One is to test if the servlet runs for a GET request, because that's all it was supposed to be doing. So, when I do, I'm basically reading the test now. So, when I call a do get on the servlet by passing in the request and response, I get a result back, and then I want to just see if the result was what I expected. Similarly, the second one is going to test if the servlet in fact does not allow post request, because if you remember, my actual servlet implementation was only for a get request. So when I make a post call on the servlet, I want to see if an exception is thrown. So it's very easy, but that's the whole part. Let's not ignore it, and let's go to the previous one and ignore that, so that we know what we're testing, and go back to the terminal and see if it passes. Build success. Again, as you can imagine, if we look at this line, we ran 2 tests, no failures, no skipping, so all is good. All right. Coming on to the last one, and this is a bit interesting. I have to be frank, we don't have much of these either, but I think this is useful to kind of show the power and what you can actually do in pretty much similar ways. So what this is doing is, as you can see from the name over there, make it a bit more bigger, is my awesome servlet functional spock test. So as you know, a functional test is to actually make a real connection to the servlet, or in this case to an author instance for CQ at 4502, and test the path. So in this case, the path is /bin/test my awesome servlet, and you want to actually see if the servlet API is, or the REST API in this case, is up and running. Obviously, if you want to make a real connection, you need an HTTP connection, because that's what we have. So this method right here, create HTTP builder, is going to give you that HTTP connection. We did not go to the details of how this is doing, but just in short, HTTP builder right over here is provided by Groovy by default. So again, using Groovy helps. You don't have to use any external libraries or write your own HTTP connection manager or something you can use quickly and get started. And obviously there are 2 functions over here. I want to see if a post request is working for a servlet, and below a get request is working for a servlet. So in this case, the do get to servlet is going to accept an HTTP connection, is going to try to make a actual request with actual get request with JSON data type as the response, and try to see if it works. So, how would the test look like? Surprise! It looks really similar to the example that we saw, and that's good. We don't want people to learn new things if it's not needed. So, the first one about test a post request to the servlet, given an HTTP builder for a given servlet path. So over here, if you can see, this is different than what we had before. This is not really doing anything in terms of the test itself. It is merely for readability purposes. And again, this will help a lot if new person coming on, you'll exactly say what the things are given for the test data that you're trying to write. And again, the similar when clause, when I make a post request with some data, then it should return successfully. The second test. So I forgot to mention what this servlet is doing. This servlet, which is installed currently on CQ, has implementations for only post requests. So it will not accept get requests. And that's what we're trying to test over here. So similarly, we have given an HTTP connection. When we make a do get call, then it should throw an exception. In this case, it will try to parse out the JSON response, and it will fail because it will be a stack trace that will be returned, saying that method not allowed. So obviously, as you can imagine, we'll try to run it now. And comment out the other one. Hopefully, so this test should make a real connection, and it should succeed unless my author instance is not working anymore. It is working. So build success, and if we look, this is giving us an stack trace. If you see what it says, that is actually what we expected in this case, because if you remember, that servlet is not supposed to accept any get calls. So that's what the response is saying. The first one passed fine, but the second one said, I got an exception because I was trying to parse a JSON response, but I got an exception or invalid JSON response instead. So these were some examples of how you can do testing using Spock for CQ specific purposes when we went through some examples. So this is a lot to take in. I would like to stop and see if there are any questions at this point.
So you mentioned actually the marking suddenly, especially when you are writing integration test cases, that's really important.
Yes.
How do you go beyond just simply creating the objects, especially say your logic is dependent on accessing some data from the repository itself. And often with Sling actually they have their own mock objects as well, application framework.
Yes.
Do you guys use that? If not, what do you replace that with?
Yeah, so we have some cases like that, what you mentioned. I think we actually have extended the Sling's testing API, so I think they provide mock objects for the request and response and things like that. What we are doing is, I think there is a custom implementation of extending that a little bit more to provide support to JCR calls. Like for example, you are trying to access resources over factory or Sling repository or things like that. So there is some custom implementation on their side for testing purposes only to test out those part of things. So it is kind of like mocking. You're not really making real calls because it is not a functional test. If you want to do an integration test for a piece of code that talks to the JCR, you can do that using that custom implementation.
I think Time Warner Cable has a proprietary mocking API called Jackalope. It's explicitly for mocking JCR resources and nodes.
And if you look at the API itself, it's not terribly hard. I know Scott had looked at it recently, and it's not daunting, but it's obviously big one. So, any other questions? All right. So, we already talked about this, but just kind of making sure that we have it on the plate. So, what all can you do using Spock? As you can see from these points, pretty much anything. Integration test, unit test. I didn't show an example of an integration test, but as you can see, we saw unit test and a functional test, which looks really the same. So you can imagine that integration test doesn't look that much different. We have cases where we have some external databases and we wanted to have integration tests, and it is pretty much the same. Functional tests and even UI tests. So you can use Spock along with Jeb or Selenium, and you can achieve browser automation for your websites to do some testing on the UI part of it. So see if the page is rendering correctly or things like that. That is also possible. One other point about this, which I think is really important, and this is what actually gets everything together. It is just not enough to have only a lot of tests. I think what will provide real value is if you have those tests automated. What I mean by that is basically after every build, after say a new deploy, or if you merge your code to master, there should be an automated build kicked off, and which would actually validate that your code base is sound or not. So that's what I meant by test automation. It is going to help in continuous delivery, because if you have test automation, you can basically use these tests, which are run in an automated way, as means to catch errors before they actually go to production. So simple errors like null pointers, which occur a lot, and other kinds of exceptions, or simple use cases that you missed. If you have automated tests, continuous delivery and integration is going to be useful. So, kind of wrapping up at this point. Where to go from here? Because this is, write test first, or the technical definition of TDD is an ideal case. That's not going to be the case for every use case that you can think of. There can be projects which are well into their, in 6-month phase and things like that. You don't really have to start big. You don't really have to start from zero and, oh, I want to write tests for every piece of code. But what you can do is add tests to the code that is important for your particular use case, or write tests to the code that needs change. So going forward, you can start easing in to the TDD methodology. Say there is a new implementation altogether. Start writing tests first, or start writing test period for your implementations, and hopefully make everyone's life easier for you who is writing the code, for the person who is reviewing your code, and lastly for the person who is maintaining your code. So we talked about art of programming at the start, right? So kind of answering the question over here. What I believe is the art of programming really lies in being a good being a good programmer that has the mindset of writing tests and can write code and eventually write tests that humans can understand, and not just write code for the computers to execute. And hopefully, tests will help in that case. It will just be a sound approach. That's it.
So what are the instances where you, I don't know, when you talk about the good side of it, I guess, let me ask you a question from a different angle as well. Now suddenly I think this one be for everyone, or this one fit I think in every situation. So based on your experience, what have been some instances where you think this is applicable, or you were writing test cases and you just thought it's a burdensome or a waste of artificial bandwidth to write test cases because it's not adding any value in terms of the code to quality.
Yeah, for sure. It has happened. So in short, we should have method to madness, and you have to be you have to be diligent of writing tests, but there should be some person who is acting as a gatekeeper, or yourself if you get to that experience level, saying that I have to do this part of the code, or I have to fix this part of the code. Especially for bug fixes, it is important to write a test for it, because a bug fix basically means that you missed a use case, unless it's a null pointer. If a bug fix is for a feature that you missed, writing a test for it is going to make it exactly. So in these cases, it is going to be important. But in other cases where it's a minor change, it's not that important. I cannot really give of concrete examples. Maybe Jeff or Scott or others who have used that for a while also along with me. But yeah, it depends. If there is good peer support, if there are people reviewing, understanding it, then they'll say that this doesn't really need 15 tests for this part of code.
Just to follow up with that, so do you guys actually write or requirement to write the test cases on before the backend, or the services in the servlet, or even the functional test cases actually are a must as a part of the features?
Very good point. So backend for sure. So at least from the part of the project that we are on, testing as a mindset was first introduced for the backend. So it's been matured enough for the backend. But recently, we have tried to do the same on the front-end side. So there are some awesome frameworks on the JavaScript testing part of it, like there is a Jazzbase.js, or there is Mocha, and things like that, which we have actually started doing. But it hasn't got that much traction yet, because frankly, there hasn't been new JavaScript on the front end. So functional aspect of it, we did make, at least right now, there have not been any new functional tests, but I think that also becomes a priority if there is a use case that calls for
So about how many tests do you have on the project that you're working on?
Unit tests is about 800 overall on the TWC Denver side. Actually, yeah, unit test is 800, integration is about 100 or so, functional is about 50.
How much time does it take actually to execute all those test cases?
On Windows, it takes more time. But if you're on a Mac, it should not, for the build to complete, it should not take more than 3 or 4 minutes.
So is that actually executing the test cases part of each and every build as well? Or
Yes.
It's a nightly process actually?
On your machine, every time you build your project, it will run unit tests. In terms of, when you say, for example, if you have a new feature and you merged your code to the main branch, there is a auto kickoff of the build process, which is done by Jenkins. So we have a Jenkins system which does all these automation things, and that will do unit tests, integration tests, functional tests, smoke tests, and all those things after you build. And if they fail, then everyone will get an email.
So when writing your test cases, do you write underneath business requirements, or do you write them to like meet the developer's needs? Like I need to make sure this is a request.
Both the things. If you like writing tests, you will do both. If not, then it will be mainly to test the business requirement. But for me personally, I do try to write it for all the cases that I can think of, and also business.
So is that kind of like the distinction between TDD and BDD, like writing test cases that meet business requirements as opposed to writing test cases that
Right. Yeah, Spock really tells you to look at any use case as a behavior. That's why behavior-driven development. So at that point, they don't really distinguish between if it's a developer-focused use case or a business-focused use case.
Is it should an aspect of BDD as opposed to TDD?
It is. The should is basically kind of a keyword, as you may, for BDD, but that really is apparent in another popular language, which is Ruby. If you use RSpec at all, the test really say should equal to that. So that's really what it says. So
Or
in this case,
or a matter of converting the acceptance criteria into the
Right,
tests themselves,
right.
so that would be more BDD.
yes, that would be more meaningful.
What can you say about the TDD mantra? Write the test, watch it fail, refactor. What can you say about that?
I think it's a good idea, but not for a project which is already going on. For a project which starts from scratch, or if there is a new thing that's going on, if you do that, then it's good, because it's going to be incredibly difficult, especially if there are no tests, and if there are no tests, and if you try to incorporate TDD as it originally says, there might be some friction.
Well, I think that's a general TDD mantra, because it's important to establish as a control the fact that you're testing what you intend to test, and watching a test fail and going back into the code and refactoring,
That's true.
and going back and forth between the test and your code itself basically assures that you're targeting the functionality of the unit that you want to.
Yep, and hopefully at that point of if you are thinking about that, you will do that anyways, because
Right.
you know about testing, you know about the Spock framework in this case, and you do that really.
Question, I don't want to put Steven you on the spot here. But a question, I think, looking at it actually from a non-secure angle, what's the difference? I think, we all worked on both the secure and non-secure when it relates to this, right, actually. So what do you see as a difference as to how you approach automated use cases with secure versus non-secure projects?
With the CQ paradigm and the OSGI paradigm, particularly, you have all the interfaces, and you have that paradigm that's kind of forced on you, which makes mocking much more obvious and natural. In other paradigms where you don't have such a model, you can mock more concrete classes, but it obviously doesn't work all the time because you're actually doing a concrete class. So it really depends on what kind of paradigms you have in your code. So if you follow an interface-based paradigm, then using Spock in the mocking framework is you can apply it anywhere in that case. So it really depends on your code and how your coding paradigms are.
That's a good point, actually. The other actually point I think, it's with ZQ, I think, at the end of the day, I think, most of the features or the work that you are doing, it relates to building web pages. So does that make actually just the writing the test cases itself a lot more complex with ZQ applications versus, say, non-ZQ apps?
Sometimes it does, especially if you don't have a good support for JCR APIs and such, it can get a bit complex. And especially again, it comes down to the code quality. So if you have, you have a web application, but if you have a servlet that's spitting out HTML itself rather than a data structure which can build HTML, then obviously testing that servlet is going to be incredibly difficult. So it comes down to the code quality. If you have good gatekeepers in your project, then make sure that it doesn't happen.
Not even servlets, but to convolute your view with scriptlet code actually makes it harder to test, and that is another reason
That is a
why
good
you
point,
should
yeah.
pull that logic into a back-end model.
Yeah, so you have these JSPs, a component which is a wrapper component. It has 5 child components. If you are using JSP just for templating and not for writing Java code inside that, and if you have a component model, MVC architecture, then writing tests for that would be easy. Otherwise, honestly.
That speaks to your point earlier about writing tests kind of get you in the mindset of good separation concerns, overall good software. So it's separating your view.
Ryan, you had some question.
I reconsidered. I
Okay.
don't have it anymore.
Anything else? Okay. Thank you.
All right. Just a second. Thank you. All right, so with that, thanks again everybody for coming by. Your next meetup actually on 8 July. So product manager, actually the senior product manager from Adobe, is going to come by, and in fact that time we'll have a lot of folks. I think I know people from NASCAR actually, from Charlotte actually, they are going to come by as well. We have other business users actually from here. AICPA, and of course, so as everybody is interested in learning more about AEM 6.0, the changes actually that are part of that, as well as I know a lot of you have technical questions. So the next session I'm really excited about basically, and we'll have that actually in a different venue, and I'll send out the details around that sometime later this week. But with that, thanks again, everybody.
Do we know the topic for that?
AEM 6.0.
It is focused on
It's focused on AEM 6.0. So the person actually initially I said Rick was going to come by, but now looks like actually it's going to be the person who is working really closely on AEM product suite and has a both a functional and technical background as well. His name is Matthias Siegel. So he's going to come by. Actually, he's going to be here, and I know I think a lot of questions actually with AEM 6.0. I think that people have around the technology itself, since it's not just the functional changes. I think there are a lot of technical or the framework changes around JCR. So hopefully, I think we should be able to answer, provide some more insights into those technical changes in the platform. All right. Thank you. Thanks, sir. Same here.
I know, gee,